Welcome to College Algebra Resuscitation. Today we're going to work on finding complex zeros for a polynomial. So the polynomial we're going to be working with is f of x equals x cubed minus 8x squared plus 25x minus 26. Our first task is to find any rational zeros for this polynomial. In order to do that, we need to find all of the values for p, which are the factors of 26. So p would be plus or minus 1, plus or minus 26, plus and minus 2, and plus and minus 13. We also need to find q. Q is all the factors of the leading coefficient, which in this case is 1. So q equals plus or minus 1. We then find p divided by q, and since we're only dividing by plus and minus 1, we simply end up with all of the values for p. And these are all of the possible rational zeros. Now to speed things up, I've graphed this function. You could graph this on your calculator. And we see that there's a 0 at 2. We really should check this. If you were to plug 2 in for x here, you would in fact find that f of 2 equals 0. So we know that positive 2 is a rational zero for this polynomial. Our next step is to factor x minus 2 out of this polynomial. We do this using synthetic division. I'm going to place my x cubed coefficient here, my x squared coefficient here, my x coefficient here, and my constant coefficient right here. And then we carry out synthetic division. As before, I'll drop the 1 down, multiply by 2, minus 8 plus 2 is minus 6, 2 times minus 6 is minus 12, 25 minus 12 is 13, 2 times 13 is 26. And minus 26 plus 26 is 0. So this remainder of 0 confirms for us that 2 is in fact a rational zero of this polynomial. Now what our synthetic division has also told us is that x minus 2 times x squared, because this is the x squared coefficient, minus 6x, because this is the x coefficient, plus 13, because this is the constant coefficient. If I were to multiply this term, x minus 2 by this trinomial, we would end up with our original f of x. So now we need to factor this part in order to find the complex zeros. We're going to do this using the quadratic formula. So as always, a is 1, the coefficient of x squared, b will be minus 6, and c will be positive 13. So I take minus b, which will be 6, plus or minus the square root of b squared, which will be 36, minus 4ac, and this will all be over 2a, which is 2. 4 times 13 is 52, and 36 minus 52 is negative 16. This is a negative sign in front of the 16, divided by 2. I can simplify this as 6 plus or minus square root of 16 times square root of negative 1 divided by 2. The square root of 16 is 4. And for the square root of negative 1, we've defined that as I. Divided by 2. And now I can cancel a 2 out of the top and bottom. And now I've obtained two complex zeros for this polynomial. 3 plus 2i and 3 minus 2i. So now we have the fully factored form of this polynomial, which is and if we were to multiply these three binomials together, we would obtain our original f of x. So that's how you find the complex zeros for a polynomial.